In this presentation, we will consider a general strategy for factoring polynomials, putting all our previous techniques together. We will present a set of general guidelines followed by a variety of examples. Our guidelines consist of essentially 3 steps. First, factor out any common monomial factors from the polynomial. Second, to continue factoring, consider the number of terms in each factor. For factors with 2 terms, look for a difference of squares or for a difference or sum of cubes. For 3-term factors, try the method for factoring quadratic trinomials. For factors with 4 terms, consider factoring by grouping. Finally, be sure to factor completely by reconsidering each factor for further factorization. Instructions will be to factor completely. Let's factor 5x squared minus 80. We notice a common factor of 5 that we can factor out, leaving a second factor of x squared minus 16. Since x squared minus 16 is the difference of squares, we can factor that into x minus 4 times x plus 4. Therefore, 5x squared minus 80 can be factored as 5 times x minus 4 times x plus 4. For example 2, let's factor 3x to the 4th minus 48. We notice a common factor of 3, which we can factor out, leaving a factor of x to the 4th minus 16. X to the 4th minus 16 is a difference of squares, which can be factored as x squared minus 4 times x squared plus 4. Now we have a factor that is itself a difference of squares that can be factored further. Therefore, our original polynomial 3x to the 4th minus 48 can be factored as the constant 3 times x minus 2 times x plus 2 times x squared plus 4. Now let's factor minus x to the 5th plus 2x to the 4th plus 35x cubed. We have a common factor of x cubed, but because the leading coefficient is negative, we factor out a negative x cubed, leaving a quadratic of x squared minus 2x minus 35. This trinomial can be factored if we can find 2 numbers that multiply to negative 35 and add to negative 2. Negative 7 and plus 5 satisfy those requirements, and therefore our original polynomial factors as a minus x cubed times a x minus 7 times x plus 5. In example 4, we wish to factor x cubed minus 7x squared minus 4x minus 28. We don't have a common monomial to all 4 terms, and with a 4-term polynomial, we consider factoring by grouping. Grouping the first pair of terms and the 3rd and 4th terms together. We can factor x squared out from the first pair of terms and factor a negative 4 out of the second pair. This leaves a common binomial factor of x minus 7 that can be factored out, leaving another factor of x squared minus 4. We can continue factoring the difference of squares, and we get that our original cubic can be factored x minus 2 plus x times x plus 2 times x minus 7. To factor minus 2x squared plus 8x minus 8, we notice that all of our coefficients are even, so we can factor out a 2, but our leading coefficient is negative, so we actually factor out a negative 2. The remaining trinomial factor, x squared minus 4x plus 4, has the form for a potential perfect square trinomial. X minus 2 times x minus 2 does factor correctly. So I have that my original minus 2x squared plus 8x minus 8 can be factored as the constant minus 2 times the quantity x minus 2 squared. Now let's consider the quadratic trinomial 6x squared minus 21x minus 45. Before jumping in with our quadratic trinomial techniques, it's useful to notice that all the coefficients are divisible by 3. So factoring out a common factor of 3 leaves me with a trinomial of the form 2x squared minus 7x minus 15. We know that to factor this trinomial, we would need two numbers that would multiply to negative 30 and add to negative 7. Negative 10 and positive 3 have those properties. Furthermore, I notice that if I'm going to factor, I'm going to have something of the form 2x plus or minus something times x plus or minus something else. We can find the missing terms, noticing that our outer product and our inner product need to give us coefficients of negative 10 and positive 3. To make the outer product have a coefficient of negative 10 requires that the 2x be multiplied by minus 5. To make the inner product have a coefficient of 3 requires that the x be multiplied by 3. Therefore, 6x squared minus 21x minus 25 can be factored as the constant 3 times 2x plus 3 times x minus 5. Now let's factor 2x cubed minus 250. Notice that both terms have even coefficients, and when we factor out 2, we're left with x cubed minus 125 as our second factor. This is a difference of cubes, x cubed minus 5 cubed. So using the SOAP rules, we get x minus 5 times x squared opposite sign 5x, always positive 5 squared. Remember that in factoring the sum or difference of cubes, the trinomial factor will be prime if all monomial factors are taken out in step 1. X squared plus 5x plus 25 is a prime trinomial and won't factor more. Let's consider one final example to factor x cubed plus x minus 2 cubed. expanding x minus 2 cubed will not be helpful when we want to factor. So we notice that we have the sum of cubes with bases x and x minus 2. We can use the SOAP rules to factor. We get the first base plus, same sign, the second base, times the first base squared, minus, which is the opposite sign, the product of the two bases, plus, always positive, the last base squared. Now several steps of simplification will produce that we have 2 times x minus 1 times x squared minus 2x plus 4. So our original sum factors to a product of 3 factors, 2 times x minus 1 times the prime quadratic x squared minus 2x plus 4.